Today is a talk I'm giving called Welcome to Programming. If you remember last time I gave a talk called Welcome to Your Computer. These constitute a 4-part educational series about learning about technology and getting technical in your startup. So last time we got technical. I made the, guess or hope that you guys who are not technical, maybe you wanted to know what you need to do to get technical actually. So I introduced you to your command line and gave you full access to your computer. And hopefully I made the case that getting technical is not as hard as you had thought. My grand point of all of these is that if you learn about your computer, which you started, and if you learn about programming, which you'll do today, and then you learn about how the infrastructure of the internet works, you will be more or less technical and able to make smart, intelligent, technical decisions and even start coding yourself. Maybe it's not the most exciting thing, but I believe it's empowering, it's money-saving, and I dare say fun. I had this realization the other day. I was doing some Ruby tests, and I was converting this problem was converting DNA to RNA, some strings, and I was like, this is like my video games now. I used to play a lot of video games, and I haven't played them in years, and I kind of realized that making stuff for the web had filled that need for me. And maybe if you learn this, it can fill that need for you also. Because all of you look like lost souls, with something missing from your life. Yeah, you do. So I'm just gonna start with coding is nice. You probably work on business problems all day and getting users and talking to people, and so just terrible thing. So I'm gonna say this program, consider the benefits of taking some time out to actually just work on a logic problem, not how it makes you feel doing a crossword or something like that. This has the same benefits, and it'll also really expand your thinking and how you approach problems. I know learning coding has definitely done that for me. But maybe you feel like coding is too hard or not worth the effort, or you just don't want to. But what if you didn't know it? What if you've been coding your whole life? So we'll talk about that today. That's I get into my TED Talk voice. Every TED Talk begins with what if everything you knew about rocks was wrong? So I like doing that. So in this talk today we'll do 3 things. We'll do some non-computer exercises, that's why laptops are down, to show that coding really is just organizing your thoughts. Then I'll go over the commonalities all languages share. So whether you learn Ruby or C or Haskell or Scala, you'll know that the things you're learning are actually very similar. And then I'll talk about some practical options to learning coding. Okay? So this begins presentation 2. Welcome to programming. Show of hands. Who has learned a programming language in school? Okay, so 1, 2, 3. Kenny, you obviously did. 1, 2, 3, 4, 5, 6, 7. So okay, there's a lot of you, but some of you haven't. Who hasn't? I guess. You guys. Okay. Trick question. You all learned at least one programming language in school.
You totally got me.
I know, it's your calculator. That is actually a programming language that you learned a long time ago. As a kid, as a little dumb kid, you learned how to use the calculator. So exercise 1. Programming actually can really be broadly thought of as data and instructions. So I want you to take 2 minutes and write down how you would explain someone how to use a calculator that hasn't used a calculator before. And I want you to think of it in terms of data and instructions, and then tell me how you combine those 2 things to produce some results with the calculator. And then try and tell me about those results. This might sound a little vague, but I just want you to start thinking about what you're seeing on your calculator. So take 2 minutes and do that right now. I can play a song. Call that time. So let's talk about something which you have. Ram, what did you write down?
I wrote that it is a program that looks here with mathematical functions, and so you input numbers and the operations, and it spits out the results.
It spits out the results. So what results did you say it spit out?
Other numbers.
Other numbers. Okay. Okay, Molly, what'd you write?
I said that you type numbers in, and those are instructions that represent data. And then when you use the plus, minus, times, or divide functions, that's also instructions that are like specifically saying for the calculator to do something to come up with the results, which is also data.
Okay, and anyone else? Noah, what'd you write?
I wrote, there's going to be input and output.
There's what?
Input and output.
Okay.
So for input, you basically put in numbers and data, and you build a relationship with functions, for example, plus and minus, and you get the output in the end.
Okay. Okay. That's interesting. So I think I noticed that Ran and Molly actually thought about the problem a little differently, because you called your numbers instructions too, instructions for data, and you didn't make that. So it is possible to actually think about something as simple as a calculator in a different way. So what I would say about the calculator is that you break it out into data and instructions. So the numbers are the data, and then the operators are the instructions that you're applying to them. And they have a certain syntax that you see on this calculator, which is rules for combining data and instructions. So if you look at our calculator, we took our data, our numbers, 9 and 7, and then we added them together with an instruction of plus, and then we get 16, and that's a new piece of data that we're producing out. And that at its core is exactly what all of programming is. You're taking some set of data, manipulating it, and then you're getting some third new set of data. If you ever get lost in the morass of what is this program doing, just go back to that single statement and you'll be able to find yourself. So all programming languages share these features. They all have data. Can you think of a programming language or a computer application that doesn't have some type of data? I would challenge anyone to try and actually think of one. It doesn't exist. And they all have instructions, whether it's as simple as how to turn itself off and on or what to do. But they all differ in one way, and that's syntax. That's how you combine data and instructions together to make your computer do something really meaningful. Even a calculator. So you're used to the notation at the top. It's called infix notation. You say 1 plus 2 times 3 equals, right? There's actually another very prominent calculator notation, I assume mostly used in Poland, because it's called reverse Polish notation.
It's used in finance.
Oh, it is? Okay.
A lot.
So there you go. You notice that you're doing 1, and then you're hitting enter, then you're doing 2, and you're hitting enter, then 3 and enter, and then you're putting in your operators after that, multiply and plus. Funny story, in Texas there's a thing called UIL, which is an academic like decathlon you go to. And I did the calculator challenge, so you had to go take a test and answer everything with the calculator. And the teacher gave me a reverse Polish notation calculator that I had never used when I got in there. So I was able to answer 0 out of 60 questions.
No.
Yeah, but I learned about reverse Polish notation, so knew it existed. So no matter what, no matter how you actually do it, all of these operators produce the same thing. They produce the number 7, but they're combining the order of their data and instructions differently. So in a nutshell, that's what programming is. If I'm to drive it home, it's data and instructions. So what we'll do is we'll move on to our second exercise now and illustrate another key idea about programming. Exercise 2. I want to read this out loud. You come home from work, sitting in your kitchen, fresh out of its crate is the newest killer device from Apple, the Roneesh bot. Your fingers tingle with trepidation as you peel off the saran wrap that says wrapped by Apple in California. The Roneesh bot will do anything you ask it to. This could get very interesting. You decide to be wild. You ask it to make you a sandwich. Roneesh bot, make me a PB&J. But it just stands there and it doesn't move. You say now, and it doesn't move. And it just sits there and it grins at you like an idiot. Where's your damn sandwich? You flip through the manual, and here it is. You must tell your Roneesh bot exactly what you want, or it won't do anything except grin at you like an idiot. Sincerely, Tim Cook. So, exercise 2. You need to tell Roneesh bot how to give you a PB&J sandwich, or any sandwich if you have a peanut allergy. I won't judge. Here's some constraints for the problem. Any method you can get this robot to obtain you a sandwich is a valid method. I just need a sandwich in the hand. Down every step you're going to tell this robot to take to procure you a sandwich. So this will actually be kind of involved. So I'm going to give you guys 5 minutes, and I want you guys to start. There's a robot in your kitchen grinning at you like a moron. Give it the instructions to give you a sandwich. Go. So, given your results, I will go over. Could your Roneesh bot make you a PB&J sandwich? So Sam, it looks like you wrote a fair bit. You want to read over what you wrote?
Okay. Go to the cabinet, pull out the bread in your left RoboClaw, pull out a jar of peanut butter in your right RoboClaw, place it on the counter by the sink, turn and open the fridge, take out a jar of jam, turn and place it on the counter by the sink beside the peanut butter jar, open the lid of jelly, and place it on the counter beside the jam jar. Same with peanut butter. Reach below you to pull open the silverware drawer, pull out a butter knife, and close the silver drawer, dip the knife into the peanut butter jar and lift it back out. Spread both slices of bread with peanut butter, spread it evenly into the edge of the crust. No preferences included. Repeat with jelly. Put one piece of bread on top of the other, cut the sandwich.
Okay, that's really thorough. What was your step 1?
Go to the cabinet.
How does your robot know what cabinet to go to?
Well, I guess he doesn't.
Okay, what was your step 2?
Pull out the bread.
Pull out the bread. Does your robot know what bread is?
Well, he better.
So you can see some things that it seems like it's thorough instructions to you, but actually your robot doesn't know any of those things. And one thing you said was, I think you said instruction was look below you, right? Even something like below that is so intuitive to us that would bewilder a computer. Tarek, do you want to read yours?
Yeah, it's not even thorough, but it's probably less so. Is it go into the cupboard and get the bread, go into the adjacent cupboard, get a plate, place both on the counter, take out 2 slices of bread from the bag, put them on the plate, go into the cupboard, get the peanut butter, go into the fridge, get the jelly, open both jars, go into the drawer, get a butter knife, stick the butter knife in the peanut butter, spread it on 1 slice of bread, get a new knife, stick it in the jelly, spread on the other slice of bread, put the 2 pieces of bread together, and voila.
Okay, cool. So you guys wrote really similar instructions, so the same thing would apply to that you defined a lot of things that you intuitively know, but you can't really assume your robot knows. Did anyone do anything that didn't involve like going in your own kitchen? Yeah, Jen.
I told the Arbot to take the phone out of my hand, press and hold the home key on the phone, and when prompted, ask Siri to call the nearest place that delivers PB&J. And then when someone finishes talking, tell that place to have them deliver 1 PB&J to this address via cash. And then we sat around and played cards for a while. And then when the door knocked, I told the robot to walk over to the door and scare away the driver so he didn't have to pay, and then walk the sandwich back to me.
Oh, cool. So actually, what Jen did was something that is a little better, because Jen told her robot to start talking to another robot, and computers are actually really good at talking to other robots. And she also told the robot to just recite some text into the phone. A computer can do that pretty well. If you give it some input, it can spit it right back out as output. Noah, what did you end up writing?
So I told the robot to go to allrecipe.com
Yes.
Search for given J. And just click on the first results. Look at the instructions and search them on Google. Use image match. So use that image to match the things actually are in the kitchen that I have, and put all those together according to the instructions.
And of course your cabinets have doors on them, so it's easy for them to find it.
Yes.
Okay. So yeah, actually what Noah began to do was what's called using an API. That's using someone else's code to do a service on your own site. And so what he said was, hey robot, access this other site's API and find all the sandwich info and then bring it back and then use that to make a sandwich. So I would say both of you guys' instructions are like halfway there actually. Those could honestly halfway work. So really cool.
What does API stand for?
API stands for Application Programming Interface. What it actually, its definition is really nebulous, but basically it's code you didn't write and you use. And sometimes you pay for it, so.
Literally and figuratively.
Literally and figuratively. So what I wanted to illustrate with that example is just the fundamental divide. The core problem everyone will encounter with programming is that you're just not descriptive enough in your program. That's it. Humans are better than computers in so many ways. Like, if anyone's ever like, oh yeah, robots are going to take over one day, just have them do this exercise and point out that if they can't make a sandwich, they can't beat us in a war, I promise you. So yeah, we know so many things intuitively, what bread is, where to get it, how to pull it out of a bag, how to open a jar, what a jar is. All those things you have to tell a computer program. We have to tell them literally everything we want them to do, or they look back at us like just like a dog looking at you, basically. So to summarize, programming is just data and instructions combined with some rules you call syntax. And I'm going to say a swear word, you fuck it up by not being descriptive enough. And if you are writing a program and it's breaking, just ask yourself one thing. Does the computer know what I'm asking it to do right now? And the answer will always be no if it's breaking. That you're just not telling it what number to do some operation to or where it is right now. It's missing that data and it's just up to you to provide that. That's all programming really is. So that was part one where we just talked about what programming is. Now I'll talk about part two, which is commonalities. So I said that programming languages share one key idea, all of them. They manipulate data and instructions to produce something. Generally more data, but actually as you get more advanced in programming, they'll manipulate data instructions to produce more instructions, and that's where programming gets really fun and kind of strange. So what is data? That's a good question to ask before you start programming. Like, what is the data you'll be manipulating? So I want you to do another exercise. I want you to describe yourself in data and use whatever data you feel is relevant and whatever form of data you think is relevant to you. So I'll give you guys 2 minutes and just describe yourself in any way you see fit. Oh, Jen. Jen drew a picture of herself.
Using ones and zeros.
That's really cool. That's really clever. So, she used ones and zeros, which I think you all know that's at a core what a computer comprehends is leaps and bloops. And then you drew an image, which is, isn't that a really common type of data now, actually? If you think of the internet 10 years ago, images didn't play as large a role as they do now. Now everything's like Facebook and images and all that stuff. So yeah, that's cool. I was hoping someone would draw a picture. Please let someone draw. So yeah, as you can see, data is not just limited to the simplest thing you can think of. Sound waves, that's data too. Anything pretty much can be data. But what is computer data? So specifically, and you guys mostly held to this, numbers, 1, 2, 3, 1.5, pi, stuff like that. And strings, hello world, that's the canonical string you first write when you write your first program. You should have it output hello world. Roneesh would be a string. And then one thing that we didn't get from talking to you guys was Booleans, the concept of true or false. We did with Jen actually, sorry. She wrote 1 and 0. 0 0 is false and 1 is true in the computer's terminology. And you use that to make an image. Very cool. So yeah, I mean, computer data is not the most terribly complex thing, actually. Like, people say big data and all these buzzwords around it, but the one thing to keep in mind is that it's still just strings and numbers and booleans. And also composite data, which is kind of what Molly goes on to. Right? So programs take our basic types of data, they combine them into a little more complicated forms of data to make managing them easier. So a simple one is an array, right? Roneesh, 28, programmer. And then a little more complex one would be like a hash that said name, Roneesh, age 28, programmer, true. And then, just like what Molly said, objects, like, which is basically like a nested hash of sorts. First name Roneesh, last name Bashish, age 25, I wish, I'm 28. And then like my address, right? That's an object within my object. So you notice that as we went down the list, they got gradually more descriptive. The array at the top, it said Roneesh and 28 and programmer, but it actually didn't tell you what the context of those pieces of data were, right? But then if you just go to a hash, which is another type of computer data, it's getting a lot more descriptive. Now I know that name is Roneesh, his age is 28, and whether he's a programmer or not, that's true. So as you work with, when you try and learn a language like Ruby or JavaScript now, you'll find yourself working a lot with hashes and objects, actually. And my favorite person in the world, my programming teacher, Jeff Cohen, he would, in his really squeaky voice, he'd go, "It's a hash!" And that's his answer to every problem. Don't freak out, it's just a hash. All of Ruby on Rails, which we'll go over in like 2 weeks, mostly a hash. That's it. If you understand what's going on in a hash and an array, and that it's just passing those things around, like, you can understand Ruby on Rails really simply. So that's computer data. But now we're going to talk about instructions. Remember I said that we need data and then we have instructions. So we're going to do another exercise. I want you to describe to me how you make the decision about who you'll go on a date with. And I want you to think about what makes you agree or not to agree to go on a date with someone. And what instructions would you give yourself to make the best decision about your date? And don't worry, no one is taking notes. We're not trying to figure out how to ask someone out. So yeah, 2 minutes, let's go. Most common ones are conditionals, cases, and loops, and we'll look at those. So Kenny had a conditional, right? He said age less than or equal to him. So this is a good example. This would be mine, I guess, right? If their age is less than 18, I probably won't date them, because that's probably illegal. If their age is greater than 40, it would just be too much of a generation gap. And if they're pretty rich, I'm gonna, yeah, all that goes away. We can date, I guess.
What a computer understand that? Give you numbers?
I'd have to give it a net worth, right? So yeah, even these things, like when you go through your daily life, you are doing these conditionals really obviously, actually. Like, you are making this if-then-else statement. There's also cases. Cases are a pretty common type of instruction across computers. So yeah, this is mine. I would totally date a barista. You guys see me drink coffee all the time. I would definitely date an engineer. Dominatrix date. I must have put that in and then forgot to take that out when I was writing it. But yeah, I'd totally give it a try just to see what that's like. Republican strategist. No, I would not date Republican strategist. So yeah, you guys all have that too, right? I mean, you had cases in your list of people to date. Smart, intelligent, funny, and all that. And then if those things had evaluated to false, then you probably wouldn't date that person. Finally, you have loops. None of you in your criteria for dating someone went through a loop. It's kind of a little more complex instruction, so you can be forgiven. But when you do find out someone to date and you inevitably mess things up, you might want to go through a loop. So for I is equal to 0, while I is less than the number of times you messed up, in this case 20, you would want to buy her a flower. And then increment I every time. So you'll buy her 20 flowers. And that's a for loop, and that's, for most of your programming that you do like in a web application, that's kind of the most complex conditional or loop or logic that you might actually even come across. So, and that's it really in terms of the similarities. They share similarities with data, and they share similarities with instructions that they can give each other. That's across all programming languages.